So for the next talk, we are going to have a talk in English for the first time and for the only time today. Thank you very much, Pascal, for doing it in English. So despite the fireworks you see on the background, I thought it was for New Year, but apparently everything can explode in this talk. So I will let the floor to Pascal, leave it as prudent as I can. And so here is a talk about resilient application.
Thank you. Hi, everyone. Mein Name ist Pascal, ich bin Franzose, ich spreche kein Deutsch, and last time I did this talk, it was in Germany, hence the German. But this is a talk you may have heard in 2019 or 2021, and today I'm going to do it in English. You have a transcript in French. It has been posted on Slack 6 minutes ago. Many years ago, I was working as a consultant, and very early one morning, a colleague and I, we got into a car and we left Lyon. We were going for a journey, a couple of hours, to go meet a customer. And we are French, so of course, while driving, we are already thinking of the great lunch we will have with our customer. You know, relaxed settings and talking after a hard half day of work. So we arrive and we work hard. We had lots of stuff to discuss, lots of questions that were waiting for answers. But at some point, one guy at the customer, he asks us to guarantee the application will always work. Really, guarantee and always work. So my colleague and I, we look at each other and we tell him, sorry, we cannot guarantee that. And then the guy tells us, you cannot say that to a customer. We're like, we look at each other again, and yeah, we just did. After all, we don't lie, we are honest, and we know bad things happen. Yeah, you may have guessed, things didn't go so well after that, and a while later, my colleague and I, we ate eating alone in a fast food on a motorway service area. It was not a great lunch, and it was not with our customer. I'm Pascal Martin, I'm a principal engineer and an AWS hero. I work mostly on infrastructure and backend, AWS, Kubernetes, and matters such as performance, resiliency, stability, and costs. And I work at Bedrock. You already know Bedrock, so I will skip this part. And since this story, I've thought a lot, or I've grown up, and now I work on applications that are more visible, maybe. And I realized that many of us want a service that's always operational. I want that. And even if I remain convinced that it is not possible to never suffer from any failure, maybe we can raise our odds. And that's why we are going to talk about resiliency today. But before talking about resiliency, let's talk about nines. What are nines? Well, nines are a measure of the availability of an application, basically. So you can say we have 29% of unavailability, 29% of availability, sorry, and we can be unavailable for 3.5 days every year. That's okay. Or you can promise 4 nines of availability, and so you can be unavailable 63 minutes per year. But we never speak about yearly, we speak monthly. So when you promise 4 nines of availability, you can only be unavailable 4.5 minutes every month. Let's say if you deploy a bug, you have to fix it very fast. Nice trick. Someone could tell you, we promise 49% of availability outside of planned maintenances. That's a great trick. We do it. Now, what is availability? Well, for example, a service is operational X 9% of a time period, a month. Or X% of requests succeed. Or maybe X% of requests get an answer in less than a certain number of milliseconds. Or for video, X% of video starts successfully. And you can have great availability. You can have 4 nines over the year. But if your 1 hour of unavailability is the exact wrong day, give this. In France, once a year, we must submit a form to our fiscal administration to declare how much money we've gotten during the year, salaries, investments, and everything. And I'm pretty sure the website of our tax office works almost all the time. But even with 4 nines of availability, if your 63 minutes of unavailability are the last day to submit the form, well, here's the result. Now, percentage of requests that fail, users don't care. What matters to your users, to your customers, it's other metrics. Or rather, it's that what they are trying to do works. For example, it's Black Friday today. Users want that adding a product to a cart works. Or maybe when I'm reading a newspaper, I want the article page to load fast. Or when I go eat in a restaurant, please not a fast food, I want my carte ticket restaurant to work. I want to be able to pay. And it doesn't always. Basically, nines don't matter if users aren't happy. You may have heard microservices will save you. They will solve all your problems. But no, sorry, there is no magic. And let's take this simple case, a web application that depends on one API and nothing else. How do we calculate the theoretical availability of the web page? It's kind of easy. If the API has 4 nines of availability, then the web page that depends on nothing else has 4 nines of availability. Okay, things are great. And that's the glop 2. Smiley. Now, a bit more complex. User, web page, and the web page depends on one API and a second API, and nothing else. Our developers are good, are efficient, so both APIs are 4 nines of availability. Now we could say, okay, the web page is available, in theory, 4 nines% of the time. But no, this is wrong. As the web page depends on both APIs, the availability rates multiply, and the web page, in theory, is only available 3 nines and something% of the time. That's still easy. Now, this, more complex and likely closer to reality for many of our applications. APIs that depend on each other in every direction. Okay, what's the theoretical availability of the web page? Good question. But in fact, it's even worse. Some of those APIs, they depend on databases, on Redis, on Elasticsearch. And each of those may also fail. Okay, what's the theoretical availability? Good question. And don't forget, each service you are depending upon, they promise their own availability, or they don't even make any promise. So what can you promise for your own application? For example, this is RDS, the relational database at AWS. When I created this slide 2-3 years ago, they said, okay, we can be unavailable 21.5 minutes every month. This means if you develop an application that has a strong dependency on RDS, you cannot promise 4 nines of availability for your API. Just not possible. And by the way, an SLA, it's not a guarantee that things will work. It's more like, if it doesn't work for more than X% of the time, and if you ask for this, and if you prove the impact a downtime had, then maybe we will refund you a portion of what you had paid. Okay. Will this compensate for the money you didn't get while your platform was down? Will it compensate for the impact on your brand? Not so sure. But let's go back to this. We don't send requests to APIs and databases using their IP addresses. No, instead, we use their machines or domain names. which means that every request depends on a DNS service to be operational. And now, if someone asks you to calculate the theoretical availability of your platform, you are likely like this. So I leave you in the company of my adorable young cat. She's named Bucket. She's adorable, isn't she? And I'll wish you good luck to calculate the theoretical availability of your platform. In fact, if all your microservices communicate with each other, you have just created a distributed monolith. And distributed systems, they are fun, yes, but they are not easy. So we've seen a bit of theory, we've talked about nines, we've shown theoretical availability is not easy to calculate. Now let's talk a bit about real life. And some years ago, we were beginning to move our infrastructure to the cloud, and a colleague and I, we went to a conference called QCon in London. It's a great conference with many people from large and well-known companies, think Netflix or Airbnb, these kind of things. And during one of the first talks, we heard this. Things are going to fail. It's a fact. Okay. It's a bit surprising witnessing someone unseen being that honest. It was also a bit refreshing. And then, during another talk later in the day, we heard everything will fail over time. Okay, second speaker saying this. And then again, at scale, things fail a lot. So, okay, we have these people from great companies. They are speaking in front of hundreds of people, and they dare admit things don't work all the time. That's more than interesting. And to be honest, it kind of matches our observations on our own platform. Basically, I will go to this quote, and I love this quote. It's from an article online, and the title of my talk comes from here. And it says, distributed systems are never up. They exist in a constant state of partially degraded service. And I'm not talking about infrastructure problem or code problem. No, everything can fail. So, well, let's move on with an example based on real facts. Once again, a web page and a user. And now maybe you are beginning to understand why my colleagues forbid me to do anything visible on our applications. So here I am. The web page depends on an API, depends on another API, the second API depends on a database, and the web page also depends on C, which also depends on A. Well, it's a bit of a mess, but everything is going well, and users are happy. I think we also have this one on Slack. But at some point, developers for the A API deploy a new version of the application. And it's a bit buggy. Maybe there is an infinite loop or something like this. And A calls B a lot more. So B calls its database a lot more. And the database doesn't have any auto-scaling mechanism. So it starts to slow down, and at some point it even crashes. B depends on the database, so B crashes. A depends on B, so A crashes. C crashes, the web page crashes, and users are not happy anymore. This one also exists on Slack. And that's at that point, you realize, okay, a long time ago, we developed a web service that used this database. And that web service is still used by a partner website. And that partner website has users. The database is down. So the web service is down, the website is down, and users of our partner's website are not happy. One CEO takes his telephone, calls the other, and people are panicking and running around in the office. I move from the image because this one is so cute. Oh. Basically, when an application blows up, the impact it has on other applications around it is called the blast radius. And the more the blast radius of an app is reduced, the less a failure will impact other applications. In the example we have just seen, well, the blast radius of application A was our entire platform, and the platform was a partner. And someday something will break. That's life. If we want to answer our users' expectations, the blast radius of each component of our platform cannot be the entire platform. And a little story, one day, when Bucket was still a small kitten, I got a big package from Amazon, and it was filled with a lot of protective paper in it. That's the photo here. And Bucket, she loved playing in it, so I let it in my living room. And a few days later, there was paper everywhere in my apartment. Yeah, the blast radius of this package, when attacked by a kitten, was an entire 3-room apartment. I learned I could reduce this blast radius with a simple trick. I could close doors. Maybe we can do the same things with our applications. So there's hope, and some tools can help us, and understanding a couple of notions can also be useful. First, we need to know what our application is doing, how it is behaving. Else, we won't know if it's working well, if it's beginning to show signs of duress, or if it's going down. So we often speak about observability and its 3 pillars: logs, metrics, and distributed traces. And I know those may cost a lot. You can have lots of metrics, high cardinality of your metrics, and you will need lots of money to store them. And distributed tracing, you cannot store all traces, so you will need to do some sampling. But okay, those can still be useful. Now a bit of vocabulary. We'll talk about 3 things. The first is SLIs. I for indicator. An SLI is a qualitative measure of one aspect of service level. Okay, and all 4 things are important. And I know calculating SLIs may be difficult, and we may want to do some compromises, work with rates, averages, or percentiles. What's an SLI? Let's see some examples. First, latency is an indicator. Our application needs X milliseconds to answer some kind of requests. Error rate is another one. It's very often used. X% of requests fail. Throughput, yet another. We can handle X requests per second. Availability, we talked about it before. And durability, we have X% of chances a file will still exist after 1 year. Those are indicators. There are no value in here, only X's. Now we can move on to objectives. And an objective, an SLO, is a target value for one service level measured by an SLI. And of course, choosing objectives is hard. Yeah. How much work are you ready to do to reach these goals? That's the important question. Examples? Okay. Latency, for example. Our objective can be to answer some kind of request in less than 25 milliseconds. Our objective can be to have less than 0.01% of failing requests. We may have as goal to handle more than 250 requests per second. Availability, we talked about it. And durability, our goal can be, 49% of chances a file will still exist next year. And having goals is great. It's extremely useful. It's a powerful tool. When you have goals, you can define rules. For example, if service level is greater than the objective, yeah, you are free to do whatever you want. You can break things. You can develop new features. And you can experiment. You are doing better than the objective. Go for it. On the other hand, if your service level is lower than your objective, you cannot break things anymore. Maybe it's time to stop working on new features, and maybe you should stabilize your platform. And now we can talk about SLAs. And very often we say SLAs for SLIs plus SLOs, but it's kind of wrong. We can only move to SLAs when you have indicators and objectives. And an SLA is only a contract with customers or users. And this contract specifies consequences if we do not reach our objectives. And of course, these contracts are linked to business questions and product decisions. So let's try to summarize SLIs, SLOs, and SLAs. We could say Our API must successfully answer to 99% of requests it receives during a calendar month. We have here the indicator in blue and the objective in green. The 99% is the objective. And now we can move on to the agreement. If we don't honor that agreement, we'll give you some reduction on your bill. And please ask your legal team for advice, and these 2 sentences will morph into 15 pages of contracts. But when we have all this, when we have metrics and logs, we can set up alerts. I don't have a live duck, so this was... And the role of alerts is to tell us when our application starts getting unwell, so we can avoid a failure, or to tell us when the application has gone down, so we can repair it. And of course, alerts are great, alerts can be useful, but when Slack looks like this every morning or every evening or every day, well, truth be told, the first person who arrives in the office and goes to the alerts channel, the first person goes grab a coffee and not fix stuff. Anyway, considering the number of alerts, there must still be some stuff that's operational. Things are much better now, but 5 to 7 years ago, yeah, it was less that. An alert must only ring when there is something to be done. So alerts only when one must do something. And the alert must be actionable. There must be something that someone can do to fix the problem. For example, we don't need an alert when an AWS availability zone is down. When AWS loses a data center, we don't need an alert. There is nothing we can do. Don't wake somebody up. Our platform is already architected to survive when an AZ fails. And if some component was not designed this way, well, it's too late anyway. Now, let's see 2 metrics. You have application A that uses 30% of CPU, and you have application B that uses 90% of CPU. Okay, 2 questions for you. Which application is the best? And do we have to wake someone to do something? I don't know. I don't know. Maybe application A is slow as hell, and maybe application B is working perfectly fine. I don't know. CPU usage doesn't mean anything. What matters is how do users feel. That's important. The app using 30% of CPU, it may cause a lot of frustration and pain for your users. And the one using 90% of CPU, maybe it's just perfectly optimized and not wasting any resource. And please take your SLOs into account. If you are doing better than your objective, you do not need to wake somebody up at the first error. No, let people sleep. And talking about waking people, let's say you have application A, B, and C is down, C fails. Will you wake up the team that manages C, managing B, or managing A? And you cannot call a joker because we are the joker today. Well, if C here is broken, it's the team that manages C that can repair it. So the team managing C must get the alert. But quite often, I see the team managing B getting an alert because they are the one calling C and they are the one seeing that C is broken. So no, please wake the team of this service. How do we enhance resiliency? Let's see a few ideas. First, we do not improvise. We do things in staging, we write documentations, and then we follow this documentation when we act in production. Or even better, we automate. We write infrastructure as code, for example. And not improvising is also asking questions, asking the right questions in advance. The right questions, what are they? Well, for example, what is going to break? And how is it going to break? And how do we know it's broken? And how do we investigate? And not, I did not ask if it is going to break. I know it will. Now, as developers, please use short timeouts. An example, you have users, application, and the application depends on this service, and this service is broken or slow or whatever. And so we have a request, the request goes, and why should your app keep waiting, using resources all the while, when the users are gone? Users don't wait. No, stop waiting and return something useful to the user before they are gone. Maybe an error message, or even better, a partial response. But don't waste resources waiting for an answer that nobody will ever see. And even worse, quite often, when I talk with developers, they often tell me, the service usually answers in 10 milliseconds, but we have used 1 second as timeout, just in case. But if a service usually answers in 10 milliseconds, a timeout of 1 second is 100 times longer than the usual. And do you know how your application behaves when it waits 100 times longer than the usual? Well, I do. It explodes. It's going to explode, absolutely. Typically, that's because waiting with open connections uses resources. For example, with PHP FPM, a process can only handle one HTTP request at a time, and it's used even when it's waiting. And you do not have 100 times the number of processes compared to what you need. Some of the technical solutions, feature flipping. Feature flipping is great. You can disable feature when they crash or when they use a lot of resources. Even better, maybe you could do this automatically. Why not? And I'm sorry. I've been a developer for a very long time, and I know that we crash our applications when we develop new things. We do bugs, after all. So maybe we should do careful deployments. Instead of rolling out features to all users, maybe deliver feature to 1% or 5% of users, validate it works, and then roll out to everyone, doing blue-green deployments or canary deployments. And also, well, load tests, they can be a very good way to move towards enhancing resiliency of a platform. And this is especially true if the platform is often suffering when there is a lot of traffic. It will not help against bugs and software failures, but it will help for load. So run load tests, and you will see it's a good way to learn how to investigate when there is a problem. And this without the added stress of it's 9 p.m. and the platform is down, or even worse, it's 3 a.m. and the platform is down. And so if you have a lot of traffic, you will set up some auto-scaling on your applications, and please don't auto-scale on CPU. We've seen before, CPU means pretty much nothing. No, you should auto-scale based on how users feel. And we don't do this currently, but maybe someday we will. A good way to enhance resiliency is to use redundancy. For example, you have an application, very big application, and it uses a database. Well, create a read replica of this database. And when the primary server fails, well, stop using it and switch to the read replica and promote it to primary. The application will keep working, and it will work fine, maybe after a very short downtime, and this will cost twice as much, yes, but resiliency will be much higher. And you can go even farther. Yeah. Why deploy our platform only in Paris? No, we could also deploy in Frankfurt and London. This way, our platform would resist a flood in Paris. And we can go even further and deploy in several regions around the world. Our platform would resist a meteorite striking Europe. We would have other problems, yeah, I guess, but still, yeah. Of course, this costs a lot of money, and it requires an awful lot of work, and it has a far greater environmental impact. So maybe you don't need this. Also, replicating data in Europe, it takes 12 milliseconds. Replicating data around the world, it takes hundreds of milliseconds. So you might suffer from replication lag. I talked about microservices before. Let's go for another round. Top of the screen, you have the typical schema: web page calls A, calls B, and B as a database. Now, when B fails, A fails. Yeah, because A depends on B, and users are not happy. I think this is glop, not number, no, paglop. It's called paglop, not number 2. Those are not microservices. Those are fake microservices, because A depends on B. Bottom of the screen, you have a new architecture. The web page depends on A, and that's it. And somewhere else, you have B and its database. And when something is updated on B, then B pushes an information to A using an asynchronous mechanism. A never calls B directly. It means A must store the data on its own side with its own database. Yeah, more work. But also, if B fails, A still works. Those are true microservices. And I'm not the only one saying this. Microservices without asynchronous communication are as good or bad as writing a monolithic app. Now, when I talk about resiliency to developers, most of them, some of you even, tell me I will add some cache. And thing is, caching is not a mechanism to add resiliency. No, it's the opposite, actually. You are introducing two distinct behaviors. The data is in cache and I use it, or the data is not in cache and I call an API or a database. Two behaviors, it's more variability, more risk. But okay, let's talk about cache. When we do cache, we have an application, a database, or an API, and we add a cache layer in between. When the application starts, the cache is empty, and we go to the database again and again and again to load data. The database suffers, but after a while, all is good, and we are using data from the cache. But after some time, after 60 minutes, for example, all the entries we created in cache at the same time when the application started, they all expire. So again, we go to the database a lot, and the database suffers. But then, all is good. And this scenario repeats itself every 60 minutes. We could do better. Let's start again. App, cache, and database. The application starts, okay, the cache is empty, so we go to the database. We could pre-warm the cache. It's a question for tomorrow. And then we use the cache, and everything is well. But now we don't wait 60 minutes. No, after 50 and something minutes, one entry expires from the cache. So we go to the database for this one entry. 2 minutes later, another entry expires. So we go to the database for this one entry, and so on, for many minutes. And here we are. Instead of going to the database for pretty much all entries every 60 minutes, we have spread the load on the database between 50 and 70 minutes. Basically, we have added a random duration on our cache, 60 plus or minus 10 minutes. This is called random jitter, and this is used a lot for cache durations. This way, caches don't expire at the same time. But it can be used for many other things. For example, the crons. We put all crons at 4 a.m. because nobody is using the site at this time. No. The website is going to be so slow at 4 a.m. and I've been awakened because of this, so please don't do that ever. Spread the crons between midnight and 7. It will be perfectly fine. Same thing for session durations, for tokens validity, for everything. Spread the load. Things will be harder to debug, yes, but they will also be more resilient. And then let's talk about retries. You know, a request to an API fails. Retry it. Maybe it will work the second time. Or even better, a request takes a lot of time. Cancel it and try again. Maybe it will work the second time. But be careful. Imagine you have this. Request, success. Sorry, it's blue, it's, no, not blue, green and red. Sorry for the colors. Some requests fail. Okay, you retry the request. But more requests fail. So again, more red and some retries. Later, more red and retries of the retries. And after a while, you have a lot of red and many retries because you keep retrying again and again. After a while, your server is burning and you are retrying all of this and your entire platform is down. No. Retries, yes, but a limited number of retries. Maybe 1, maybe 0. And you will wait longer and longer between each retry. A service fails, don't call it again just now. Wait, I don't know, 10 milliseconds. If it fails again, wait 50 milliseconds. If it waits again, wait, I don't know, 200 milliseconds. And then stop retrying, the user has gone away. In the end, admitting that everything can and will fail, it will force us to set up some kind of degraded mode. Let's take another example. Website for a newspaper. I worked for several of those in the past. It looks a bit like this. You have the article, the textual content people want to see, and you have lots of other things around it, like photos, galleries, live information blogs, weather forecast, ads, many ads, more ads. Well, now imagine the API used to generate one of the blocks is down. You have a choice. You can crash everything and display nothing, or you can just not display that single block. That's much better for the users, don't you think? And if performance go down, maybe you can disable another block, and yet many other blocks. And after a while, you will display this. This is the textual content people wanted to see. For user experience, displaying this is much better than an ugly error page, or even better than the default error page of the browser. Other examples of degraded mode? Well, again, Black Friday. Let's say I have a wish list that contains 10 articles, 10 products. If you cannot load data for one of these products, don't crash the entire page. Display the 9 other products. Maybe I will buy one of those 9. Or going further, in the order funnel, when I want to order, I have 4 products in my cart, and you cannot load one of those 4 products for some reason. Don't crash the entire order. No, let me order 3 products, and then send me a mail saying me, we are very sorry, there has been a problem with your order. 1 product was not ordered. But come back tomorrow. We guarantee we will fix the problem by tomorrow, and we will give you 10% reduction. I have already ordered 3 products from your website. I will wait for tomorrow and 10% reduction. If you had crashed the entire order, I would leave your website, I would go to Amazon, and I will never come again to your website. And you could also display non-personalized data, and this will lower load on your servers a lot. Of course, if you set up, or when you set up a degraded mode, you need to think about the impacts this has on user satisfaction and business performance, which means you need to know how to measure those impacts with business SLIs and SLOs. Those are not specific to tech teams. And another idea now. Let's take again this fake microservice architecture. And let's say the database is starting to slow down. I don't know. Usually, we just let everything fail, which is bad for user experience, of course. But what if, instead, we chose to cut 10% of requests entering the network? Just 10%. Maybe it will help the database survive, and then users will be happy. I know, setting this up, it requires courage, because it means 10% of users will not be satisfied, but we will still have 90% of users who will access the application. And 90% is much better than 0. And this should also be applied in distributed architectures and distributed monoliths, where applications call each other all the time. And I cannot do a talk about resiliency without mentioning chaos engineering and simplifying quite a bit. Chaos engineering is a state of mind where you anticipate that everything can and will fail, and the more frequent the breakdowns, the better tolerated they are. So maybe you should cause the end of the world in production, see how things fail, and learn how to repair them. And that's one thing we do at Bedrock. We use AWS Spot instances for our cluster, our Kubernetes cluster, where pretty much all applications are deployed. Those Spot instances, they don't cost much, so they are 70% less expensive than others, but Amazon can retake them, reclaim them at any point, and they only tell us 2 minutes maximum in advance. Amazon retakes instances dozens of times every day, and it works very fine. We are used to losing servers. This is not a problem anymore. In the beginning, it was. We moved to the cloud between 2018 and 2020, and going over a few ideas very quickly. The cloud is great, it's elastic, there is auto repairability, there is high availability, but please don't forget that everything has a cost, and complexity may be kind of high, and the SLAs of managed services are not necessarily what you hope they are. Read the fine lines. And when I go to work in the morning, my goal is not to code an API. It's not either to configure servers. It's not to deploy an application. No, my goal is to provide a service to our customers and users. And maybe all of us, developers, sysadmin, product owners, and others, we should move towards the same goal and kind of share the same job. Maybe it will help. And we're in a conference, and I'm so tired of conference-driven development. Please choose boring technologies. I know MySQL is not hype. Maybe you think it's not fun, but at 3 a.m., you will find some documentation to restart it. The last NoSQL thingy that's very hype, nothing on Stack Overflow. Good luck at 3 a.m. I don't mean to never use new technologies, but choose wisely. For some things, using one new technology, yes, maybe it's the right tool, but for others, maybe it's not. And even with great efforts, you cannot guarantee that everything will always work. And as many others said, an incident, it will happen. So when it does, communicate, take care of yourself and your colleagues, get some sleep. When we are tired, we don't work very well. Don't panic. Keep working the same way you are usually doing, maybe pair programming, pair debugging. And when the incident is over, write a postmortem. It will help to prevent the same incident from occurring ever again. And it will help for the next incidents. Plural. Now, so what? In the end, well, we all have lots of work to do. And it's kind of up to us to strike the right balance between the effort required and the resiliency and availability needs of our platform. And I realize I did not define resiliency. So resiliency is a story of the outage that didn't happen. And I'd like to show this quote a second time. I really like it. Distributed systems are never up. They exist in a constant state of partially degraded service. And it's up to each one of us to ensure that a problem on one component on the platform doesn't lead to a platform that's entirely broken and doesn't answer the expectations of the users. I'm Pascal Martin. I've been a PHP developer for a very long time. I've been a lead DevOps. I'm now a principal engineer here at Bedrock. I'm also an AWS hero. And I know it's time to eat, so I will move away from the scene. But if you want to chat, if you have questions, please come see me. Thank you very much.